Hello everyone. Today I'll be discussing about the statistical forecast and one of the key feature that SAP IBP provides, that is a best fit model and how it can be used. So let's look at a simple scenario that we'll be going through in the demo. The actuals quantity that has the shipment history from the execution system, that is the ECC or the S4 or any other legacy system. The actuals quantity stores the shipment history in the IBP. It will be a primary input for our forecasting model. We'll select the forecasting model based on the past data, and then we'll generate the statistical forecast quantity. So we'll be going through some of the questions such as how to choose a forecast model. Now this is a very important process for a demand planner or for a forecaster, how to choose a forecast model. So with an increasing number of complexity over the years, there has been many forecasting techniques which has developed, and each forecasting technique has a unique application. The forecaster or a demand planner generally selects a forecasting model. So if a model technique is selected correctly, it will give a proper result with a high accuracy. But how to choose a forecasting model? The selection of a method usually depends on many factors. Some of the factors are, like for example, the availability of the past data, that how much data do you have for the past horizon, like 6 months of data, 12 months of data, 36 months of data. So the more the data, the better picture you will get in as a forecast, and it will have a higher accuracy. Then the second thing is the accuracy, how much of accuracy you are looking forward to. The other one could be the time period for which you are going to do a forecasting. So next 24 months, next 12 months, and how do you want to do a forecasting at a monthly level or a weekly level. So these are the few factors that influence of selection of forecast model. So, but one important thing that a forecaster and demand planner should know is the forecast is essential for marketing and sales personnel, because they given their input in order to generate a consensus demand plan, and this consensus demand plan forms a primary input for a supply planner to carry out the supply planning. As well as this forecast is a input for us executives to make their budget plans. So a demand planner or a forecaster, whoever carries out statistical forecast, need to select a technique very efficiently so that it gives a proper result with a high accuracy. Then the best fit model. What is this and how you can use it? So suppose a scenario wherein your past 12 months of data, where a planner or a user is not sure whether it is having a trend or a mix of trend or seasonality, and the planner is not sure of. Now the forecaster is not sure of. Then instead of using a double exponential or a triple exponential, you can use both in the best fit model. The IBP proposes it where you can use mix of two. You can take both the algorithms into place, and based on some parameter, like for example based on error measures, the system provides you a solution. The system suggests to you which forecasting technique should be used, and it gives an output in the form of statistical forecast quantity. So suppose there is 12 months of data, past data, and I'm not sure about the whether it is a trend or whether it's following a trend plus seasonality. So what I'll do is I'll choose both the algorithm, this double exponential and a triple exponential, and based on the error measure such as the MAPE, the system will suggest that, hey, look, your MAPE is 60% when you select triple exponential, and MAPE is 20% when you select a double exponential. It will give the value also in the business log, and system will throw an output where you will see the highest accuracy numbers will be copied to the statistical forecast quantity key figure, which will form an input for the sales and the marketing people to carry out the consensus demand plan and thereonwards. So, to make a lot of these things simple, this technique is provided by SAP IBP. So we will be looking in the case of the best fit model, where in an example we will be using two model techniques and how an error or a error measure is calculating and suggesting the values. Now, use of accuracy and errors in alert type. So this will actually help a user or a planner to focus on a specific product or a product customer or a product line customer or a product group, wherein the figures are not that accurate, and a user or planner can look back into the historical data in order to see that what has caused the problem. So this you can configure in the SAP IBP based on a few of the selections, and it will generate. So suppose a requirement is whenever there is an accuracy less than 70%, I want to see the product and customer combination for which the accuracy is less than 70%. So I can generate an alert based on this requirement that whenever the accuracy is less than 70%, it will give the product and customer combination, so that I can look into that whether that needs a different model or the past data have not been captured correctly, or whatever may be the reason. There could be a number of reasons for this. So let's get into the system. This is my planning book, wherein I have an actuals quantity, and with the removal of outliers and the missing values, the pre-processing steps, I have got my actuals quantity adjusted without any outliers and no missing values. This will be my primary input for the stat forecast model. This is the app through which we can carry out the statistical forecasting. Let's get into this app, Manage Forecast Model. So, a user can create a new stat forecast model, choose your planning area, provide a model name over here. So let's say simple moving average. We'll give a short description over here, simple moving average. Periodicity, I would like to carry the forecasting at a periodic level of week. You can choose a month or a quarter as well. Historical period, I would like to have a data of the history of past 54 weeks. So it typically depends upon the data that you have in the system. Suppose you have a past 2 years of data, then you can choose 108 weeks. If you have a past 1 year data, then you can choose a 54 week. I would like to carry out the forecasting for next 54 weeks. So I'll choose here the forecast periods as 54. If there is any offset, I would like to have it in the historical or the forecasting period, I can very well enter here. Let's move on to pre-processing step. As the pre-processing step has been carried out in a different step, so I will not use any pre-processing step over here. The forecasting step, my main input for forecasting step. So as said, after carrying out the outlier correction and removal of missing values, I have my data saved in actuals quantity adjusted key figure, so I'll choose this as the main input. My target key figure would be stat forecast quantity. I'll take this as the target key figure. Now here consider product life cycle information. This part is not covered today. However, if you choose this, if you select this particular option, then product life cycle would be considered whenever there will be a forecasting step is carried out, whenever this particular model is carried out. Now the target key figure for ex post forecast, the ex post forecast will come this on this particular thing later on, whereas we can choose an ex post forecast quantity. We can select an algorithm from here, so I will choose a simple moving average. I'll give a number of periods and then I can save this. So this is how a forecast model has been selected and it can carry out in an SAP IBP. But however, if a demand planner is not confident or is not sure about which forecasting model to be chosen in order to carry out the forecasting method, then in that case we can use a best fit model. A best fit model can have more than one model. So let's get into the best fit model and we'll see how a best fit model carries out. So I have taken this best fit model. I've already configured this best fit model in my planning area. We'll look into this best fit model. So I've given a model name, the periodicity level, the lowest bucket level at which I would like to carry out my statistical forecasting is at a week. The historical period is 24 weeks and forecasting period is 54 weeks. So remember, whatever periodicity level you choose over here is corresponding to this. So if I choose a week, then it corresponds to 24 week, the historical period. The forecast period corresponds to 54 week. Let's quickly go into the forecasting steps. I have my actual set quantity adjusted as a main input and statistical forecasting quantity as the output. I have selected two different forecasting models because I was not sure whether my past historical data only contains a trend or a past historical data contains a trend as well as a seasonality. So I've chosen the two different algorithms. That is, the first one is the triple exponential smoothing. Let's talk about triple exponential smoothing. This is a periods in a session, periods in a season. So I am looking into the past 12 periods of the 54 historical periods. I can increase this to 54 as well. But remember, the periods in a season is less than equal to what you have in the historical period in your general parameters. The type of seasonality. So there we have two options, additive and the multiplicative seasonality. The additive seasonality, if your seasonality is not increasing every year, then you can choose additive seasonality. It's more or less, it remains a constant. The seasonality that your data is having is more or less constant. But if it is increasing every year or every seasonal period it is increasing, then you should choose a multiplicative seasonality. The alpha constant, the alpha coefficient, the alpha, beta and the gamma varies from 0 to 1. The alpha coefficient, it shows the smoothing of the historical key figure data. So if I choose 0.3, it will smoothen out the historical data. If it is more to the 1, then the priority will be given to the nearest past. The beta coefficient, it is for the trend. So I've given as 0.3 because I want my trend to be trend of all my past should be taken into. When I carry out a statistical forecasting, my trend of all the past should be taken into. If I want a recent trend to be taken into consideration, then I will have to choose a beta which is closer to 1. A gamma, it is for the seasonality index. The seasonality coefficient that I gave, it's the same. If it is closer to 1, then a seasonality of the recent past would be given a higher priority. Then there is an option of enable trend dampening. When I select this enable trend dampening, what it will do is it will smoothen out the trend for the past periods. As soon as I select enable trend dampening, you will observe that a phi coefficient will become an irritable. The phi coefficient is nothing but when it is closer to 1, it gives less importance to the trend dampening, and if it is closer to 0, it gives more importance to the trend dampening. Then you will have to select the target key figure if you want. This is not a mandatory key figure, but you can select a key figure wherein the output of the triple exponential smoothing will get saved. So I have chosen statistical forecast quantity 1. I have configured this statistical forecast quantity 1, a key figure in my planning area, and then I have selected this. Remember, you should have a different key figure in both the target key figure for forecast. So that's the reason why I have configured a new key figure, that is the statistical forecast quantity 1, where I will be saving the results of the triple exponential smoothing. You can also select an ex post forecast, a different key figure for this, but I'm okay with the single ex post forecast quantity. It's not necessary, it's not a mandatory option for us. Then I have selected a different algorithm called as double exponential smoothing. As in the beginning I've told you that I wasn't sure that my past historical data contains only trend or seasonality as well. So the alpha coefficient, beta coefficient, the options remains the same. Again, I have selected a target key figure as a statistical forecast quantity 2. Let me go through my configuration page and I'll show you the statistical forecast quantity 1 and 2 that I have created. This is the new key figure that I have created, statistical forecast quantity 1 and quantity 2. So now, how will a system select which forecast model is correct? Based on what parameters will the system select which forecast model is correct, or which is more accurate, precisely which is more accurate? So the IBP has given us a few options to work out with. The methods are choose best forecast or calculate weighted average forecast. When I select choose best forecast, it means that it will select the best forecast based on a parameter known as measure used for forecast comparison, that is in the form of errors. So it will select based on the errors. The less error means the more accurate, and that will be the forecast model selected for my statistical forecast job. If I select a calculated weighted average forecast, then I will have to give a weighted. So a triple exponential smoothing I've given as 1 and double exponential smoothing given as 1. So it has given a weightage to both. So let us choose the best forecast. Now here you can see one more additional option, that is the test phase period. So if you specify a number in the test phase period, then what system will do is it will divide the historical period into two parts. One is the training data set and one is the test data set. So with the training data set, it will calculate the forecast with each of the algorithm, that is the double exponential, triple exponential, and compares the result with the test data set. And then it will select the best algorithm. So this is how it carries out the best fit model. And then for the forecasting phase, what it will do is the system will use the algorithm with the best forecast to calculate the forecast again. And this time it will use all the data set of the past horizon, and it will recalculate the forecasted value and it will populate it in the output key figure. So this is how test phase periods works. I have not given any test phase period. Now let us go to the post-processing steps. This is a very important step when we choose more than one statistical model. So in a post-processing step, though we have chosen a MAPE as the error, so that whatever it calculates, based on the error, it will define whether the model is having a higher accuracy or is best suited for this set of data or not. So based on the error, the system will decide which algorithm is best suited for the data set. So in the post-processing, what I'll do is I'll calculate this MAPE, and in the target key figure I will get this value. So this target key figure will actually, sorry for this. So this target key figure will actually tell me the number. We will see this in the system when we will execute the statistical forecast. Now what we'll do is we'll save this model. So let's get out of this app first. I've already saved this model. Let's go to the planning book. I have my actuals quantity adjusted after removal of outliers and insertion of the missing values. So this is my final data set that is going to be considered for my statistical forecast. So what I'll do is I'll quickly run my statistical forecast job. Here I will select my filter, select the week, best fit model, unit of measure ID, and execute it. So once I execute it, I can see the status of the job. Let us go and see the status. It is in process. Refresh it. Download this show business log. Now it is very important to see this business log. Now look at this. PRD02, that is the product. DC2, that is the location. Customer 2, that is the customer. Now here the triple exponential smoothing was carried out, as well as the double exponential smoothing was carried out, and based on the values it has calculated the MAPE. Now look at the MAPE over here in the when we are running the double exponential smoothing, it is 248.494%, and when we are carrying out triple exponential, it is giving out a MAPE of 70.93. Now you can see the lowest MAPE value was 70.931, so it chose the best forecast, right? It has chosen the triple exponential as the best forecast because of the MAPE of 70.931. Similarly, for this combination, we have got the MAPE here, and based on this MAPE, it will be chosen. So you can see the triple exponential smoothing was selected every time because the MAPE value is lesser than the MAPE of double exponential smoothing. So this is how the business log can be comprehended, and a demand planner can know and can answer why a triple exponential smoothing was selected over double exponential smoothing. Let's go to the system again. Let's go to my statistical forecast monthly worksheet, and here you can see the statistical forecast quantity has been populated. Now a very interesting figure you will see over here is this. Though if you remember, I have configured this to new key figure in order to get the output of triple and the double exponential smoothing. So you can see this is the output of the triple exponential smoothing, and this is the output of the double exponential smoothing. But based on the best fit model, the system has selected triple exponential smoothing. That's why we have this output from the triple exponential smoothing. The system has selected triple exponential smoothing as the best fit model, and this we have an output over here. Now this data looks different because of we are already crossed half of the June, and the forecasting is happening for the future period. That is the reason why we have a difference of data over here, but you can see from the July it is carried out well. So let's go and look at the forecast weekly. Now you can see over here, yes, so when you look into the weekly, you will find that the data is matching because I have removed the past week of the June when I have selected this planning book. So in this case you will see the data from the triple exponential is actually taken into statistical forecast quantity. That is the final output as the statistical forecast quantity. Now this will, the data of this key figure statistical forecast quantity will form the base for the consensus demand planning. So this is how a best fit model is used, and it makes it more efficient when the demand planner or any other user is not confident of choosing the forecast model. Then the best fit model works very efficiently, and it gives you an exact values with the parameters like the MAPE that we have chosen. We could have selected more number of accuracy types, like for example we could have chosen other error measures like MSE or root mean square error or WMAPE. We could have chosen that, and with using of these different methods, the IBP would have given you the output based on the least number of errors. Now if I choose more than one, suppose in the forecasting step I have given here MAPE, but in the post-processing step I have selected more than one. So MAPE will be there by default, but if I choose MSE or MASE, so what will happen? The system will give you the output. The system will give you the output of MSE. The system will give you the output of MSE, but it will select the model based on MAPE because we have selected MAPE as the comparison method. So it will definitely give you the three outputs, that is the MAPE, MSE and MSE, but it will only select the model based on MAPE. Let's go into the dashboard and see how the forecast looks like. So this is the dashboard. Let's refresh it. This is how the forecast looks like when you carry the statistical forecast. This is the past data and this is the future data. The system is predicting based on the past data using the triple exponential how much you should produce, how much on what key figures you should plan, your procurement, your production, everything. We'll also talk about one of the use of the errors. We can define the alerts, and based on the alerts, the management can circle out the product or the product family or the product group based on the location and the customer, where they have to look into the past figures in order to identify the models, or in order to identify the parameters, or discuss more onto that, so that they can bring down the error, and vice versa, they can increase the accuracy. So we can define the alerts over here. We have this app define and subscribe to alert, and an alert, you can see I have I have configured an alert based on at the level of customer ID and the product ID. So I have selected this model fit error, that is the MAPE more than equal to 30. So whenever there is a value more than 30 for the MAPE, what it will happen, it will give you an alert, it will generate an alert, and whenever there is an alert, the management or the demand planner can look into that particular combination of the product and the customer, and can look into the past why the error is more than 30%. Maybe they will have to revisit their model, they will have to reselect their model, maybe triple exponential is also not working and they will have to choose a different model, or maybe the seasonality is not that good, but the trends and based on the trends and based on the past history, it shows more of a flat trend, and then they will have to reselect a different model. So or maybe the data are not captured good enough in the past historical horizon. Maybe for the past 12 months the data has been captured accurately, but before that the data was not captured, or there was some manual intervention into that historical data. So there could be a number of reasons for that. So in that case, it makes it easier for a planner, for a management people to look into a particular set of data and identify the cause and to work on that. So this is all we have for today's session. Hope you all have enjoyed it. Thank you.